Okay, so ladies and gentlemen, you are welcome. So in this video, we are going to solve also another question. So the question says, and at this point, ladies and gentlemen, I want you to understand something. In physics, sometimes it is very important to know how to relate one formula with another formula. So this is how we are going to apply such relationship to solve a problem like this. So I think as you can see from the question, a 4 kilogram mass and a 1 gram mass are moving with equal kinetic energies. Full stop. The ratio of their momenta is A 1 is to 2, B 1 is to 1, C 2 is to 1, D 4 is to 1. So we are talking about the equal kinetic energy. So it means that the object 1, they have equal kinetic energy. It means that K1 is equal to KE1 is equal to KE2. That is the kinetic energy of the first object is equal to the kinetic energy of the second object. And we know that kinetic energy, ladies and gentlemen, is equal to half mv square. So how are we now going to relate this with the momentum? We know that momentum P is equal to mass times velocity. So from here, we can make V subject of the formula by dividing it through by mass. So this one will now cancel this, and then we now have V is equal to P. V is equal to P all over M. So therefore, we are going to substitute this in the first equation. So therefore now, the kinetic energy, as we said, is equal to half m v square. So where we have v square, we are going to substitute it with pm. So therefore, we now have p. We are going to have p all over m. Then we squared everything here. So if you square this, what are we going to have? We are now going to have kinetic energy is equal to half p square here. So we have m p square all over m also will carry the square. So we have half mp square all over m square. So 1m here will now take care of 1 here. So we now have kinetic energy is equal to p square all over 2m. So now let's say that, okay, the kinetic energy of the first object, that is, for the kinetic energy of the first object, we are now going to have Ke1 is equal to P square 1 and M1. So therefore, since we said the kinetic energy of K1 is something as the kinetic energy of the first object is something as the kinetic energy of the second object. So if the kinetic energy of first object is P1 square all over M1, all over 2M. So it means that the kinetic energy of the second object is going to be P square, P2 square divided by 2M2. So since they are equal, because they are moving with equal kinetic energy, that means the kinetic energy of the first object is equal to the kinetic energy of the second object. So that is why we have this here. So we have the kinetic energy of the first object as this, and then the kinetic energy of the second object as this. So what we want to get is the ratio of their momentum. So to get the ratio of their momentum, then we are now going to multiply this and divide both sides, and at the end we have P1 square all over P2 square is equal to 2M1 all over 2M2. So remember, this is a square, so we can factor it out as P1 all over P2. Then we have the square here divided by 2. Of course, here we have 2 and here we have 2. So this one will now take care of this. So we're now left with M1. We're now left with M1 all over M2. So this is square, so we can take square root both sides. Square root both sides. So this will now cancel this. Then we now have P1 all over P2 is equal to square root of M1 all over M2. So M1 is 4 and M2 is 1. So the square root of this is now going to give us P1 all over P2 is equal to 2 all over 1. So therefore the ratio now is 2 is to 1. So therefore the answer to this is option C. I hope you also enjoy this and you understand how we solve this. So ladies and gentlemen, please don't forget to follow and subscribe my YouTube, and more videos will be uploaded. This is this is solutions of some of the question from the past question paper. So please follow for more. Thank you.